Hello all, welcome to the Linux Rootkits for Red Blue Teams course on Pentester Academy. Now in this video, we'll pick up the last bit of information we are going to print about a running process, and this will be the real and effective user ID. So what is basically the real and effective user ID? Now whenever a process is started, the user ID of the owner who started the process is the real user ID of the process. So let's say I'm logged in as Vivek and I go ahead and run the ps command or invoke another bash, then the real user ID of that process is going to be my user ID. Now, apart from the real user ID, there is also something called effective user ID. Now, effective user ID is the UID of the user the process is actually acting on behalf of. Now, if you're probably wondering, well, yes, most of the time real and effective user ID are going to be the same, right? The user who started the process and the user on behalf of whom the process is acting is going to be the same. Now, in some cases where we may use set UID programs, then at that point, what ends up happening is the real user ID is the UID of the user who started the program, while the effective user ID becomes the user ID of the owner of the set UID program file. So let me give you an example. When we run the password utility to change our password, then we invoke the utility, and basically the utility will run with real user ID as me, Vivek, but because it needs power to go ahead and change the etc shadow file, which is a very privileged operation, and because it has been gone ahead and created as a set UID program, temporarily when running that program, the program's effective user ID becomes root or 0. So let's actually look at this and see how we can find all of this information. Now in our task underscore struct, what ends up happening is there is actually a field in there which is of type struct cred for credentials, called real underscore cred. And basically using this, we can go ahead and figure out information about the process. So after that, there are other things here as well, which are, we have very simple macros available. These are all convenience macros based on which we can go ahead and find the UID and the effective UID of a task very, very easily. And these are task underscore UID and task underscore EUID. And internally, it is actually acting upon the appropriate struct cred, which contains all of that information. So let's jump right in. So I've actually defined this function at the very end. And what it does is it's actually called print task owner info. And it takes a task structure's input and basically calls the convenience macros task UID and task EUID to print the real and effective user IDs. Let's actually look at some of these structures in more detail. Let's open up the file, include linux shed.h task underscore struct. And if you actually looked at the section on process credentials, you will actually find the tracer's credential if ptrace is enabled, objective and real subjective task credentials, and overridable task credentials, etc. Right? Now, apart from this, if you want to look at the cred structure, here it is. And you can clearly see, UID, GID, SUID, SGID, EUID, all of that stuff is actually there. And cred is actually a very, very core structure, and this is basically what maintains the security context of a task. Now, when we looked at task underscore struct, we actually found that there were really 2 pointers, right? And if you notice, they kind of describe it in more detail here. A task has 2 security pointers. Task real cred points to the objective context that defines that task's actual details. The objective part of this context is used whenever that task is acted upon. The task cred points to the subjective context that defines the details of how that task is going to act upon another object, right? Now, let's actually run the demo. So this can get confusing beyond a point. So what I've done is we've included that as a library in process library, a simple function. And additionally, I've gone ahead and invoked that library function down here in a section where we are printing task owner information. So print task owner info, right? So now let me go ahead and compile this module. It looks like I've already compiled it, but let's just repeat the process. Let me make sure this module isn't running from any of my tests. It isn't. So now let's actually look at any process. So let's look at our current bash 34238. So before that, let me make sure I clean everything up. And then let's do an insmod process underscore ID equals this. Let's type in the message. And what you'd find at the very end, apart from all the other info, that under task owner's information, the real and effective user ID are both 1000. And if I typed in ID here, you'd actually find that my real user ID is 1000, right? So clearly in this case, the real and effective user ID are same. Now let's actually run the password program and see what we get for that program. So I'm going to first do an rm mod, and in the other terminal, let me actually run the password program. So my bad. Okay, now the password program is running. Let's actually figure out the process ID. So this is 41518. Let's look at the kernel messages. And there you go. If you notice now, our real user ID remains 1000 because Vivek is the owner of Vivek is basically the one who started the password program, right? So he's the real owner at this point. But the effective user ID, or the user ID we are basically acting as, is 0, which is root. And you can notice that this is a perfect example of where real and effective user IDs differ. Now, developers can create their own setuid programs depend on what kind of privileged operations they want other users to be able to do on the system. And in such cases, you may find other programs with such capabilities as well, right? But as you can clearly see, this is very, very dangerous, because if the password utility has any bugs which you end up uncovering, then as a low privileged user, you may be able to run basically commands and instructions as a high privileged user and take over the system. Fantastic. So I hope this is clear. And similarly, you can figure out the GID and the effective GID. I'll leave that as an exercise to you. And that's all I had in mind for this video. Hope you enjoyed this. And if you have, please do recommend us to your friends and colleagues in the InfoSec community. Thank you.